Alright, this video is going to pick up from where we left off last class with example 7. We were noticing that the difference in example 7 and the other ones that we did last class is this coefficient. And in order to solve something with a coefficient, we're going to need to divide. So the same first step, we're going to subtract over the constant. 2x squared minus 8x equals negative 3. Divide everything by 2. And so we get x squared minus 4x equals negative 3 halves. From here, we're going to do the step that is completing the square. We take the coefficient of x, negative 4, and remember this is side work. Divide by 2. Negative 4 over 2 is negative 2. And then raise it to the second power. Negative 2 squared becomes positive 4. This is the number that we're adding to both sides. Plus 4 plus 4. So we have x squared minus 4x plus 4 equals negative 3 halves plus, I know I'm going to have to add these fractions, so I can write 4 over 1 as 8 over 2. Now the whole idea of adding that 4 was so that this is a perfect square trinomial, and so we can factor it into something squared. And that's going to be the second step value. If I factor this out, I should get x minus 2 squared equals, adding these, they have the same denominator, negative 3 plus 8 is 5 halves. That's the completed square. And now what I want to do is finish solving for x by using the square root property. Square root property is that when I take the square root of one side, I can take the square root of the other, but I have to remember that plus or minus. So we get that x minus 2 equals plus or minus the square root of 5 halves, which we need to rationalize. So x minus 2 equals plus or minus the square root of 10 over 2. Add 2 to both sides, and x equals 2 plus or minus the square root of 10 halves. Now there's two answers here, so we put it in set brackets to notate it. But again, we do not put the set brackets in Math Excel. Pause the video and do the try this. When you finish the try this, we'll continue on to example 8. So on example 8, we see the same kind of setup. This is a trinomial that's not factorable, so we're going to complete the square. Minus 8 on both sides. 3x squared minus 9x is negative 8. Divide everything by 3. X squared minus 3x is negative 8 thirds. Now notice I have this binomial. I'm going to complete the square on the negative 3. So negative 3 divided by 2 is negative 3 halves, which doesn't simplify, so that's what I square. Negative 3 halves squared is 9 over 4. That's what I'm adding to both sides. Plus 9 over 4, and that is the step that completes the square. So we have x squared minus 3x plus 9/4, which we know will factor because it's a perfect square trinomial, equals, now I have two fractions that I'm adding together, so I need an LCD. My LCD here of 3 and 4 is 12. So I multiply my top one by 4 over 4, bottom by 3, or the second one by 3 over 3. So I get negative 32 over 12 plus 27 over 12. Factoring the left-hand side, we get x minus 3 halves squared equals negative 32 plus 27 is negative 5 over 12. That is the square completed, and now to finish solving, we need to use the square root property. So the square root of the quantity of x minus 3 halves squared equals plus or minus the square root of negative 5 over 12. Now immediately I notice there's a negative in there, but that's okay because we know how to deal with that now. It's going to turn into an I. So that's something to be aware of. So we have x minus 3 halves equals, I'm going to write this as plus or minus the square root of negative 5 over the square root of 12. We'll do it in two steps. Square root of 12, 4 times 3. So this is going to become 2 times the square root of 3. the square root of negative 5, the negative will become I. So this will become I times the square root of 5. So x minus 3/2 equals plus or minus I times the square root of 5 divided by 2 times the square root of 3. Again, that has to be rationalized. Square root of 3 over square root of 3. X minus 3/2 equals plus or minus I times the square root of 15 divided by 2 times 3. Now we'll go ahead and add the 3/2 to both sides. So x equals plus 3/2 plus 3/2. 3/2 plus or minus square root of 15 over 6i. There's two answers there. Notice this is two complex, not real solutions. I'd like you to try the concept check, talk about why do you think this process is called completing the square, and we'll talk about it when I return. On the next page, we're going to look at an application. So interest, like when you put money in a bank, you earn money for how much money you have saved in the bank. That's called interest. So when you invest money, for example, storing your money in a savings account, you can earn money just by having your money in that account. Now, most bank accounts don't use simple interest, but it's one of the ways that we can start understanding the value of money that your money is earning. So the formula for simple interest that we use is I equals P times R times T, where I is the interest, just the amount of money that we made, P is the amount of money that you invested, or called the principal, R is the rate, and T is time and number of years. Okay, we're going to take that one step further and say, if I want to know how much money I have with my principal and my interest, then we're looking at what's called annuity, or we can think of it as all of my money. Okay, and the equation that we use for that is all of my money is the principal times 1 for the amount that I invested plus the rate of interest, so how much interest I'm earning, all raised to the t. So we want to use this formula. This is the formula that we're going to use, and if you need this on an assessment, I'll give it to you. So we're going to use the A equals P times 1 plus R to the T formula, and we need to find out what do these numbers represent in the variables. So let's look at example 9. We're going to use the formula to find the interest rate. This is our unknown, right? This is the one we're finding is R. If $2,000 compounded annually, so $2,000 is our initial amount. That's our principal. Compounded annually grows to $2,420 or $2,420. So that's our annuity, or all of our money after we earned the interest in 2 years, and that's our time. So we want to know A equals P times 1 plus R to the T. A is 2,420. P is 2,000 times 1 plus R raised to the T, which is 2. Our first step for solving for R, we need to isolate it. This is attached by multiplication, so we need to divide by 2,000. Those will cancel out. What we end up on this side is 1.21 equals 1 plus R squared. Notice now we have a setup for the square root property. So if I take the square root of both sides, I need a plus or minus. Square root of 1.21 is plus or minus 1.1 equals 1 plus R. Subtract 1 from both sides. Negative 1 plus or minus 1.1 equals R. Well, remember this is two answers. We have the negative 1 plus 1.1 and the negative 1 minus 1.1. Negative 1 plus 1.1 equals 0.1. Negative 1 minus 1.1 is negative 2.1. Now, my money grew, meaning it got bigger. So a negative interest rate would make it smaller. I would be losing money. So it can't be negative, which means that this is my interest rate. We like to write our interest rates as a percent. So 0.1 as a percent is 10% interest rate. Okay, there are a few examples here for you to try with completing the square. So go ahead and do all three of those try this examples, and then write a short 1 to 2 sentence summary about completing the square and the square root property. Then we'll take a look at the next section of notes, which you can grab off of the side table by my desk.